For chapter 16, the process of sensation, make sure that you know the major stages in the process of sensation. Receptors, make sure you cover all the receptors that we have covered in class. Yeah.
I was curious on the receptors. Besides the receptors, do you want to know the like how they're grouped? Like it was the type of stimulus detected.
Right. I want you to know the classification. I want you to know the names, their function, and whether or not they're slowly or fast adapting receptors. You should be able to tell me if they're internal, external, if they belong to general or special sensation.
Okay.
That's important. So you have to be able to place each receptor into the proper category of classification. Okay. Yeah, that's right. Definition of adaptation. What is adaptation? Again, review the receptors, especially the receptors for touch. We cover those receptors a lot. Again, as you learn about the receptors, you should know whether they're slowly or rapidly adapting receptors. Location of cold receptors. Location of cold receptors. Where are we found? How many cold receptors?
Cold receptors?
Yeah. Not repeat.
More than warm.
Huh?
There's more than warm receptors.
Yeah, that's a good point.
Isn't it the Meissner corpuscles?
But okay, what are the cold receptors? Tell me those. What are the cold receptors? Major cold receptors.
You're talking about like the Meissner corpuscles?
No. I don't think so. Meissner is a fine kind.
Thermoreceptors. Free nerve endings in skin.
I thought it was just thermal hot and cold.
No, it's a Merkel disc.
It's what?
Merkel.
It's
The
a
Merkel disc.
It's a Merkel disc.
I thought that was within touch also.
Merkel disc especially is fine patch receptor as well, but that's the receptor that also perceives coldness. So where is it located?
Oh, on your fingertips and your toes.
Yeah, but also the skin layer. Where is it located?
Oh, in the dermis?
Epithelium.
Huh? Epithelium? What part of that? No, not epithelium.
Isn't it in the dermis?
Dermis. What part of epidermis? Okay, what was the grade of this? What part of the epidermis? Hypodermis. Okay.
It's not the granulosum.
Not
Stranosome?
Basal. Those are discs right underneath of the sternobasal. You should see that. I mean, look it up. I have a diagram where you can see those right underneath the sternobasal. Okay.
So wait, what layer was it?
Sternobasal, yeah. Now, proprioception. Cover proprioception. Review physiological role of proprioception. And what are the kinds of proprioceptors? There are several kinds of proprioceptors. We have covered them. That was the end of chapter 16. And you see, when you study proprioceptors, please study them along with the reflex arc back from chapter 12. Remember chapter 12? At the end of chapter 12, there's a reflex arc of the basic spinal reflexes. So basically review basal spinal reflexes as well. It will help you a lot to understand proprioceptors. Okay? It will make sense because when we were discussing reflex arc, we said, okay, reflex arc is initiated by the stretch receptors within the muscles, stretch receptors within the tendons, but we don't know what those receptors are and, where they're coming from. Now we know. So, review that. It will help you a lot.
You said review basal.
Review basic spinal reflexes.
Okay.
Chapter 12. Very, very, I think it's like a little less 2 or 3 pages of chapter 12. The chain of command for somatic, for a sensation, first, second, and third motor neurons, what they're conducting, and, what kind of the signals they're transmitting and where they're transmitting. We reviewed that a little bit yesterday in the lecture. Definition of first order neuron, second order neuron, third order neuron. The same pertains for the motor neurons. Now the distinction between upper motor neurons and lower motor neurons. Okay? You don't have to know these complex patterns. You don't have to know these complex, highly sophisticated networks that I showed you.
What about the?
Those spinal filament, spinal tracts. You don't have to know these. Just know the upper and lower motor neurons, how they arrange, and how they exert their effect.
What was the last part? How they're arranged and what?
And how they exert their effects, how they execute their response. So, again, we talked a little bit, maybe too much, but I just wanted to clarify what those tracks stand for. So I thought it might be interesting. So that's why I covered a little bit too much. You don't have to know that.
What about like the local circuit neurons and the cerebral neurons?
Study them too. But just, again, you have to know upper and lower motor neurons.
So you said not the local circuit neurons and the motor basal nuclei neurons and all that?
Yeah, you have to know what they are. You have to know, because, they make this, this total picture. You can't just study this huge picture separately. You can't eliminate. You can't embed the information. It wouldn't make sense. Finally, special senses. Olfaction. Again, general function of a supporting cell. General function of supporting cells. Yeah.
I was trying to look up, I know what the supporting cells are, but it asks for the functions of each of them. Would I go by, what it's made up of? I'm getting confused trying to study those for each and every sense.
Okay. But you can tell me what is the general function of supporting cells. What is the general function of supporting cells in, let's say, olfactory epithelium and in the inner ear?
They provide support, nourishment.
They provide support.
Electrical installation.
The electrical installation. And nourishment.
And they're in all senses, though, right?
For nearly all special senses.
For special senses.
Special senses.
Yes.
That's a big difference. Why they have to provide electrical installation? Well, because receptors are neurons, and neurons need a very unique, highly specific, and properly insulated electrochemical environment. So that's why they provide this installation. It's pretty much like myelination. Myelination is also like electrochemical installation of neurons. Because we have to treat receptors as neurons. Receptors are highly modified neurons. Rods, cones, hair cells are neurons, just highly modified. So. Location of taste buds, where are they located?
No, for that one too, there's like, I see, the location would be here, 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 and here, and then it says, but it's specifically on the pavilion.
No, just taste buds, just the taste, where taste buds are found in, I would say, the upper respiratory tract. They're not only found on the tongue.
Okay.
There are other sites where taste buds are found. Anatomy, external and internal anatomy of the eye, and again, as you review the external and internal anatomy of the eye, make sure you know the function of each structure. Don't just study them separately. That's important. Structure and function. Structure and function. It makes sense. Study the correct order in the flow of tears. We'll talk about that tomorrow.
I'm sorry, can you say that again, correct order?
We'll start that tomorrow. Correct order in flow of tears. We almost finished that yesterday, but we didn't have enough time, so we'll start that tomorrow. Okay? What protein is making up cells of lens?
Crystal.
Crystalline. Very good. Chambers of the eye. What are the chambers of the eye? Their name, location. Okay. Visual transduction pathway. This is something that we'll talk about tomorrow. Visual transduction pathway. How is it executed? Visual transduction pathway. How is it executed? Structure of the outer, inner, and outer, middle, and inner ear. Structures, of course, and function of outer, middle, and inner ear. Organ of Corti. We'll talk a lot about organ of Corti tomorrow.
Organ of
Corti. C-O-R-T-I. Corti. Yeah, this, remember we had these two plates on the practical, these stations, valve 13. That was organ of Corti.
Do you want us to know its location?
No, I want you to know the parts of the organ of Corti.
Okay.
Hair cells, inner hair cells, outer hair cells, through membrane.
Can you just explain something to me? As that inner part of the ear goes around the cochlea and it goes up, is the cochlea duct, do they align so that there's a fluid, or it's all separate? If I understand the way it spins around, like if you were to take a garden hose and you put in your sections so that you have the three main parts like we had on that disc.
The cochlear duct is separated.
So as it goes around, the two